My name is Rachel Shmookler. This is my first and probably only Ignite talk. I will talk about a project I worked on to extract river bathymetry data from a PDF report into a GIS, believe it or not. So the first step really was to search for data. USGS, NOAA, Fish and Wildlife Service, state agencies, nothing. So you could take a survey, but maybe it's January and the rivers are frozen, or else there's a sequester, so funds are kind of low. We accessed a report that had some great survey information for our location and time of interest, which had been used to model river depth, but it was in PDF format. So my task was to determine whether it could be extracted into a GIS. Okay, so slide. The PDF had a map of the location with river transects. And I stuck this into ArcMap and georeferenced it, and one of these transects will be used as an example throughout the presentation to go over the methodology. Okay, and there were about 100 transects which were digitized and had their IDs recorded. It is important to note that not all transects were straight, and they varied based on length and direction. So there was just no uniformity with regards to that whatsoever. So this is a vertical depth profile of a single transect, distance on the x-axis and elevation on the y-axis in feet. Again, there were about 100 of these, and the lengths all varied, so automation was the only way forward. This couldn't be manually done. So I cropped the image to the chart section, imported it into Arc as a raster, and used band 3 to extract the river profile information. It was critical to quantify the number of rows and columns to keep track of elevation and distance. So these are the points using band 3 of the river profile. All of them have associated elevation and distance values, but there's too many. It's an overrepresentation, and this can't be used for interpolation due to oversampling. So I stripped out the points in x and y space. This transect is 2,000 feet, and the highlighted point you see has a distance of 150 feet across the transect and 190 feet in elevation. Slide. So how am I doing this? Python scripting is the bulk of the work, different Python libraries, our tool sets, georeferencing, reclassifying, digitizing, and manual checking is critical to make sure everything's going smoothly, so you're just all over the place as a GIS professional. So here's the transect over there, and then here's the vertical depth profile. Now how does the depth profile have information that can locate it in space geographically? It doesn't. I had to integrate the two of them. So at this point, I kind of sat back and I thought about a few approaches to use to go forward with the workflow. And I phoned a friend, or rather a colleague in my office who's also in GIS. And he and I just sort of talked over the best way of going forward. And he introduced me to the linear referencing toolbox, which I had never used before. Specifically the make route event layer and create routes tools. These tools assign a value to a line feature based on distance from the origin. And so I created 3 route event layers based on transect orientation. I messed it up the first few times, took a couple tries, because if you do it wrong, the elevation profiles get reversed and your river's just backwards, and that makes no sense. So the create route tool generated points for each of the transects. The dark blue points are within the channel, so I had to remove all the points beyond the channel boundary and then convert from elevation to depth units. So going back to the profile image, this bottom line was used to determine the riverbank elevation. I identified that elevation value for each of the transects, and I removed all the points that were above it. And also I subtracted to get depth, So these are the points within the channel only. Yellow is 0 to 2 feet depth, and then the dark blue points are the deepest. They go up to about 75 feet in depth. Slide. Some statistics are here. One thing I didn't mention is that I used a supporting database table that had a list of all the transect IDs with associated minima and maxima for the x and y axes to keep track of those elevation and distance values. So the feel-good takeaway is that sometimes GIS can be a little bit tedious, but sometimes we get to really leverage some great tools and stretch our creativity and problem-solving skills. And I kind of had fun with this, to be honest. So shameless plug, I will be talking about the Northeast Ocean Data Portal on Wednesday afternoon. I will be discussing ocean use planning and the use of the Amazon Cloud, Flex and JavaScript web applications, and the GIS data behind it. So thanks.